Okay. I don't want to see it. For all values of x, the continuous function f is positive and decreasing. Let g be the function given by g interval 4 to 2 f derived. Okay. Which of the following could be hey, is it 4?
You know, someone's gonna have a good time listening to this. You know what? That's okay.
I can't read that.
Then why did you ask to read?
To x to 2. Which of the following could be a table for value for g?
Oh, yeah.
I literally couldn't read that.
You can't read.
That was good.
Okay, we're gonna move on. So it says it is positive and decreasing. Which one is this for? Okay, so it is positive and decreasing. So if it is decreasing, we know, let's write out g prime of x. Oh. And then we have g double prime of x. Mm-hmm. So if it is positive and decreasing, what can I say about f prime? Because we know g prime is actually f of x. Are we okay with why that is the case? If I derive g, I get g prime. If I derive, the integral goes away, right? So then on the next one we have f prime of x. So it is positive. So if this is positive, we know the graph is going to do what?
Decrease.
It's going to be above? Okay, it's going to be above the x-axis. And then if it is decreasing, what else do I know?
It's headed towards the x-axis.
That f prime is negative. Okay, now let's look at the concavity.
Literally it's the same.
Because f prime is positive, we need to make sure it's going up. So just by looking at this, -2 to 0 to 1, is that going up? Okay, so is my b going up? How about c?
No.
It is not going up. What about d? No. What about e? And if it is decreasing, that means what's really happening is it is increasing at a decreasing rate. Decreasing rate. So we're going to be adding a smaller number each time. So let's see what's happening between -2 to 0. How many are we adding? Okay. How many are we adding from 0 to 1? Let's compare the next one then. How many are we adding between these two?
2 and 3.
And is that decreasing rate or increasing rate? So we know we're looking at A. All right, so I have all this work on here. Not really work. It's rewritten. So Keith, let's try it again. Let's read 29.
Okay. The rate of change of the altitude of a hot air balloon is given by r t is equal to t to the t cubed minus 4t squared plus 6, where 0 is less than or equal to t is less than or equal to 8. Which of the following expressions gives a change in altitude of the balloon during the time of the altitude is decreasing?
So this one is asking us to compare from f prime to the f. The rate is the f prime. Okay? So if it is decreasing, if f is decreasing, what do I know about f prime? It is negative. So let's kind of use a trick on this one and use our graphing calculator. And we know numbers that are negative is below the x-axis. Is that right? So on y1, type in 0. On y2, let's type in the equation that I don't have 6, but 61. There we go. Make sure you're typing. I see most of you guys are. You're gonna graph like that in the air? Say cross where? I don't know.
I think I made it for you.
And go to Zoom 6 when you're ready. And I'm going to do a quick sketch. Just doing this. And the interval we're looking at it is from 0 to 8. So I'm only going to graph the part that's going to dip down. So let's find what that intersection is and what that one is. So we have second calc 5 to the first one. I got 1.572. Yeah?
Yes.
Okay, give me the second one. What was it? 3.514. Thank you. And with those two ranges given, on the lower and upper bound of the integral must be what letter? A?
A.
Yep.